Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and today I'm going to discuss some past paper questions from A-Level Maths P3 Cambridge 9709. The topic is differentiation. So here we have handout question number 21, which is October-November 2014, paper 32, question number 4. So the question says that the parametric equations of a curve are x is equals to 1 divided by cos cube t and y is equals to tan cube t, where t is greater than or equal to 0 less than pi over 2. The requirement of part 1 is to show that dy over dx is equals to sine t. We need to express dy over dx exactly in this form. So first thing first, we have x as a function of t, which is x is equals to 1 divided by cos cube t. Okay, so this is basically in a fractional form, meaning we are going to use the quotient rule of differentiation over here. So u is 1, so therefore u dash is 0. V is equals to cos cube t, and by chain rule we are going to find v dash function. Okay, so cos cube t essentially means cos t is whole cube. Okay, so in order to find the v dash function, the power 3 comes down, okay, multiplied as a constant. Cos t is in the bracket, we write it as it is, and then we subtract 1 from the power, so power becomes 2, and then multiplied by the derivative of cos t, which is minus sine t. Okay, so this is basically the concept of chain rule. All right, so v dash is equals to minus 3 sine t multiplied by cos square t. So far we have achieved this thing. And since we are dealing with the quotient rule, okay, so when y is equals to u over v, so dy over dx is equals to vu dash minus uv dash completely divided by v square. So the quotient rule formula is vu dash minus uv dash completely divided by v square. Okay, this is also given to you in the formula booklet. So v times u dash is cos cube t multiplied by 0 and then minus uv dash will be minus 3 sine t multiplied by cos square t and then completely divided by cos cube t whole squared. Okay, so far we have achieved this much. So 3 sine t cos square t divided by cos t is raised to the power of 6. So we write it like this: 6, a small power, just above cos and before t. Okay, so what we can see is that cos square t gets cancelled out, and here the power will remain 4 in the denominator. So we can see that dx over dt function is supposed to be 3 sine t divided by cos t raised to the power of 4. Alright, so far we have differentiated x with respect to t. I hope this thing is clear. Now we have y as the function of t, which is y is equals to tan cube t. So y is equals to tan cube t means tan t whole thing is raised to the power of 3. So by chain rule we are going to find the dy over dt function. So dy over dt is equals to the power 3 comes down, tan t we write as it is, power becomes 2 and then multiplied by the derivative of tan t, which is sec square t. Okay, so 3 tan square t multiplied by sec square t. So we have found dy over dt function, and now we are going to find the dy over dx function. So chain rule formula, dy over dx is equals to dy over dt multiplied by dt over dx. All right, so here we have three things over here, you know, dy, dt and dx. Okay, so dy over dt multiplied by dt over dx such that dt and dt gets cancelled out, and therefore you are left with dy over dx over here. This chain rule formula you are studying since P1. Okay, so you should be well versed with all of these things before attempting the possible questions. All right, so dy over dx is equals to, first we write the dy over dt function. So dy over dx is equals to, first we write the dy over dt function, which is 3 tan square t multiplied by sec square t and then multiplied by dt over dx. Okay, we have obtained dx over dt, so we are going to just make the fraction reversed, or you just say we are going to use the reciprocal of dx over dt. Okay, so this is supposed to be cos t raised to the power of 4 divided by 3 sine t. So far we have achieved this much. Now what I can do is I can use identities over here. In place of tan square t, I can write sine square t divided by cos square t. So 3 sine square t divided by cos square t multiplied by, in place of sec square t, I can write 1 upon cos square t, and this is multiplied by cos t raised to the power of 4 divided by 3 sine t. Okay, so what we are achieving so far, 3 sine square t multiplied by cos t raised to the power of 4 divided by cos t raised to the power of 4 times 3 sine t. So what we can see is that, this 3 and 3 gets cancelled out. This cos t raised to the power of 4 and cos t raised to the power of 4 gets cancelled out. And one sine is cancelled out and one sine remains over at the top. I mean, one sine gets cancelled out over here and the other one is remaining in the numerator. So all we are left with is sine t. Therefore, we have shown that, therefore, dy over dx is equals to sine t. This was the requirement of part A, which is worth 4 marks. Part 1 actually. Alright, I hope this thing is clear. So now let's move on to the next part, part 2. In part 2, it is required to show the equation of the tangent. Okay. Hence show that the equation of the tangent to the curve at the point with the parameter t is y is equals to x sine t minus tan t. As simple as that. What we know the fact is that the dy over dx function is sine t. And dy over dx basically tells you the gradient function. So t is unknown. We need the equation of tangent in terms of t. Okay, what I can say is that when I'm going to find the equation of the tangent, okay, so the gradient of the tangent is sine t, because t is unknown, right? If you have any value of t, you would be able to find the gradient very easily by just putting the value of t into this gradient function, sine t. However, the t is unknown. So the gradient is sine t, and basically the line passes through the point x comma y, right? But x is as a function of t and y is also a function of t. So basically the third variable is t over here. The parameter is t. This is basically the whole idea behind the parametric equations. So I'm going to say that the line passes through the point 1 divided by cos cube t comma tan cube t. Okay, so I'm going to say that the equation of the line y minus y1 is equals to m multiplied by x minus x1. All right. So therefore, y minus tan cube t is equals to sine t is completely multiplied by x minus 1 upon cos cube t. Okay, so now we need a specific form over here, okay? So, which is in terms of sine t and tan t. So first of all, if I make the expansion, so y minus tan cube t is equals to x sine t minus sine t divided by cos cube t. Okay, so far we have achieved this much. All right. And now what I am going to say that y minus x sine t is equals to tan cube t minus sine t divided by cos cube t. All right. So now what we can do is that, you know, what I can do is, first of all, I can use the identities over here. So tan cube t is exactly the same thing as saying sine cube t divided by cos cube t, and then minus sine t divided by cos cube t, and here we have y minus x sine t. So this is like y minus x sine t is equals to, taking sine t as common, you are left with sine square t minus 1 in the, in the numerator, divided by, you can say, cos cube t, because this is completely divided by cos cube t. All right. So what we know, the fact is that a basic identity since P1, which we are studying, that, I can say that sine square t plus cos square t is identical to 1, right? So I can also say that cos square t is identical to 1 minus sine square t. However, if I need sine square t minus 1, so I have to multiply minus sign on both sides, okay? So I can say that minus cos square t is identical to minus 1 plus sine square t. So now I can easily say that, simply say that sine square t minus 1 is identical to minus cos square t. Wonderful. Okay, so y minus x sine t is equals to sine t is multiplied by, in place of sine square t minus 1, I can write minus cos square t, and this is divided by cos cube t, and cos square gets cancelled out. So you are left with y minus x sine t is equals to minus sine t divided by cos t. And sine t over cos t is tan t. Simple. So now we get our required form. So y is equals to x sine t. I'm going to bring minus x sine t over here again. So y is equals to x sine t minus sine t over cos t, which is minus tan t. And in this way, we have shown our required equation of the tangent. As simple as that. Okay, so you need to be well versed with all of the identities, okay, and how to use them. I hope you have done enough practice in the topic trigonometry. So this was basically, you know, question number 21 of the handout, which is October-November 2014, paper 32, question number 4. So now let's move on to the next question. Okay, so the next question is question number 22, which is May-June 2015, paper 32, question number 3. It says that a curve has equation y is equals to cos x multiplied by cos 2x. Requirement is to find the x coordinate of the stationary point on the curve in the interval x is greater than 0, less than pi over 2, giving your answer correct to 3 significant figures. Okay, so first thing first, what we know, the fact is that the equation of the curve is given to us as a product of two functions. Okay, meaning equation of the curve is given to us in the form of y is equals to u times v. Okay, so dy over dx is equals to uv dash plus vu dash, uv dash plus vu dash. Okay, this formula is also given to you in the booklet as well. So u is equals to cos x, so therefore u dash is equals to minus sine x, and v is equals to cos 2x, so therefore v dash is equals to minus 2 multiplied by sine 2x. Okay, this form is also established through chain rule. Okay, you should know this thing when you differentiate cos kx with respect to x. So what you get is minus k multiplied by sine kx. So it's important to be well versed with all of these forms, before attempting the past paper questions. All right. So this was just a basic concept. Okay. So uv dash plus vu dash. All right. So dy over dx is equals to cos x multiplied by minus 2 sine 2x plus vu dash, meaning cos 2x multiplied by minus sine x. Okay, and this whole thing will be equated with 0 since we want to find the x coordinate of the stationary point on the curve. So dy over dx function is supposed to be equated with 0. All right. So therefore, in the next step, I can say that minus 2 sine 2x multiplied by cos x minus sine x multiplied by cos 2x, and this whole thing is equal to 0. So far we have achieved this thing. So now we can use some identities over here. I can say that in place of sine 2x we have 2 sine x multiplied by cos x. Okay, this identity is also given to you in booklet. So minus 2 multiplied by 2 sine x times cos x multiplied by cos x. Okay, and then minus sine x multiplied by, let's say in place of cos 2x, I can write 2 cos square x minus 1. Okay, as we know that in place of cos 2x, we can write three forms. Alright, so I've used this particular form, 2 cos square x minus 1, and let's see what I can do in the very next steps. Okay, so far what we have is minus 4 sine x multiplied by cos square x minus 2 sine x multiplied by cos square x plus sine x, and this whole thing is equal to 0. Now what I can do is I can convert this completely in the form of sine. Here we have basically multiple ways of solving this equation. Okay, so since I have achieved this much, so best way is to now completely convert this in the form of sine. Okay, in place of cos square x, I'm going to write 1 minus sine square x, the identity which you are studying since P1. Okay, so this goes on like this, minus 4 sine x multiplied by 1 minus sine square x minus sine x times 1 minus sine square x plus sine x, and this whole thing is equal to 0. So therefore, minus 4 sine x plus 4 sine cube x minus 2 sine x plus 2 sine cube x plus sine x, and this whole thing is equal to 0. Let me erase this, and there is some glitch of the pen. So plus 2 sine cube x and then plus sine x, and this whole thing is equal to 0. Okay, so far we have achieved this much. All right. So now what I can do, I can simplify the terms. So 4 sine cube x plus 2 sine cube x, this is 6 sine cube x. Okay, so 6 sine cube x, and then minus 4 sine x minus 2 sine x, this is minus 6 sine x, and then plus sine x, so this is minus 5 sine x, and this whole thing is equal to 0. So far we have achieved this much. 6 sine cube x minus 5 sine x is equal to 0. So what we are going to do, we are going to take sine x as common, multiplied by 6 sine square x minus 5, and this whole thing is equal to 0. Okay, so when sine x is basically equated with 0, all right, so these are those angles. Okay, as you know the fact that when sine and cos, when sine x and cos x are equal to plus 1, minus 1, or 0, so they make those angles which are either on the horizontal axis or the vertical axis of the unit circle, where every coordinate on the circumference of the unit circle is in the form of cos comma sine. Okay, what I'm trying to say is that when we are talking about the circle with radius 1 and center origin, every coordinate on the circumference of the unit circle is in the form of cos comma sine. So basically, when you are talking about sine x is equal to 0, so essentially you are talking about these two coordinates 1 comma 0 and minus 1 comma 0. Okay, so we can say that theta is either equal to 0, pi, 2 pi, and so on. However, if we look at the interval which is given to us in the question, x is strictly speaking between 0 and pi over 2, meaning 0 and pi over 2 are excluded. Okay, so x is equal to 0 would not be a possibility over here. So therefore, uh, we do not have any required x coordinate over here according to the equation sine x is equal to 0. Okay, we do not have any required point over here, so it is not needed. You can simply say this is not needed, or you can say just outside the interval, or you can just simply ignore it. That's perfectly fine. So this is outside the interval, or you can say ignored, or you can say rejected. All right. So if you solve this equation, sine x is equal to 0, so what you get is x is equal to 0, pi, or 2 pi, and so on. However, x is equal to 0 is excluded in the interval. So we can just simply reject it. All right. And then we have 6 sine square x minus 5. 6 sine square x minus 5 is equal to 0. So sine square x is equals to 5 over 6, meaning sine x is equals to plus minus under root of 5 over 6. Okay. So what we know the fact is that x is greater than 0, less than pi over 2. So we are talking about the first quadrant only. And in the first quadrant, sine is positive. So we are only going to take the positive value of sine x, which is positive square root of 5 over 6. So first we are going to find the basic angle alpha, which is always acute. So basic angle alpha will be equals to sine inverse under root of 5 over 6. So what is the value of sine inverse under root of 5 over 6? Your calculator must be in radian mode. Okay. This is 1.150 radians. Okay. And since sine is positive in the first quadrant and the second quadrant, however, we are talking about the first quadrant only. So 1.150, this is the only x coordinate of the stationary point in this particular interval. Okay. So therefore, यार spark हुआ थोड़ा सा कोई क्या हुआ इसको चार्ज नहीं हो रहा it's fine the laptop is charging मुझे लगा उड़ गया all right so what I'm going to say is that 1.150 is basically the only x coordinate of the stationary point. Okay, so we need to give our answer correct to three significant figures. So therefore, x is equals to 1.15 is your only answer. And there is no any other stationary point in this interval. Okay. All right. So this was basically question number 22. And for the purpose of this video, I've discussed these two questions. Okay. Basically, there was a glitch in the audio. Okay. I had to make some voice edits for this particular question, specifically this part, so I thought to record it again. So I discussed, for the sake of this particular video, I've discussed question number 21 and question number 22 over here. This one is June 2015, paper 32, question 3, and question number 21 was October-November 2014, paper 32, question number 4. All right, so I'll make more videos inshallah and I'll be uploading soon. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.